So today we start one more question of GATE 2020 mechanical set 1 paper. So without any delay, let's start the question. So the first question is: a single degree of freedom oscillator is subjected to a harmonic excitation of Ft is equal to F naught cos omega t as shown in the figure. This is the figure. This is spin constant K and the damper coefficient C, and this is the force. Then the non-zero value of omega, for which the amplitude of the force transmitted to the ground will be F naught. So we have to found the value of omega. So as the transmitted amplitude is ground to F naught, so F1 is F transmitted is equal to F naught. That means transmittivity epsilon is equal to Ft divided by F naught, as Ft is equal to F naught, so transmittivity is equal to 1. Transmissibility is equal to 1. That means transmittivity is equal to 1 when omega divided by natural frequency omega is equal to root 2. So implies that omega is equal to root 2 times of omega n, and natural frequency omega n we know, which is equal to root 2 into omega n equal to root over of k by m. So taking 2 inside the root over, we get root over of 2k by m. So the answer will be option C, root over 2k by m, the value of omega. Next question: the stress state at a point in a material under plane stress condition is equiaxial tension with a magnitude of 10 megapascal. If 1 unit on stress sigma and tau, this is normal stress and shear stress plane is 1 megapascal, then the Morse circuit represent of the state of stress is given by. The given data is equal biaxial tension only in stress shear stress diagram. So the answer will be a point on stress axis at a distance of 10 units from the origin. Next question: given data, a 4-bar mechanism is shown in figure. For the mechanism to be a crank rocker mechanism, the length of the PQ would be, so remaining 3-bar length given, and we have to find the PQ, and the condition will be crank rocker mechanism. So the crank rocker mechanism to be satisfied, we have to first satisfy the Grashof law, which is equal to length of shortest link plus length of largest link will be less than or equal to the remaining link. So let us by try with the length 80 mm. So the length of PQ is equal to shortest link. Let's take it 80 mm. The length of shortest link is 80 and the largest link is 600. T plus 600. Check LA and LB. The remaining length is 700. 300 plus 400 is 700, and 80 plus 600 is equal to 680, which is also less than or equal to 700. That means satisfy. So the length of PQ will be 80 mm. A is the right answer. Next question: the crystal structure of gamma iron austenite is, the crystal structure of gamma iron is equal to FCC. Next question: match the following. So tempering is done for softening, and functioning done for hardening, and annealing form done for softening, and normalization is done for strengthening. So option A is the correct answer. Next question. The base of brass bucket need to be rough grinded. So brass bucket is not rough grinded. For the purpose, the most suitable grinding will be. So base of the brass bucket need to be rough grinding. For this purpose, the most suitable grinding will be C30Q1 to 12B, because 30 is the grain number. So option A is the correct answer. Next, in critical path method CPM, the cost time slope of activity given by. So this is cost and this is time. This is normal time. Sorry, this is crash time, which will be too lower than the normal time, and this is normal cost, and this is crash cost, which is be higher than the normal cost. So the slope will be theta is equal to Tc minus Tn divided by Tn minus Tc, and Tc minus Tn, sorry, Tc ne, this is cost in rupees. C. Let's take RC. So this is crash cost minus normal cost divided by normal time minus crash time. So option D is the correct answer. So crash cost time slope TTL method. This is the also repeated question. D. Next, third number is the ratio of. Just a minute. Third number is inertia force to gravity force, and this is the Reynolds number. Then next question, match the following. Reynolds number, which is equal to inertia force by viscous force. Next, Grashof number, which is buoyancy force divided by viscous force. Next, Russell number, which is convective heat transfer divided by conduction heat transfer. Next, Prandtl number, which is moment of diffusivity by thermal diffusivity. So option D is the correct answer. Next question. The velocity field of an incompressible flow in a Cartesian system is represented by. b vector is equal to 2x square minus y square I cap plus b j cap plus 3k cap. Which one of the following expression is exponents for b is valid? So this is u and this is v and this is w. So for the fluid to be incompressible or to satisfy the fluid to be incompressible to satisfy this equation, del u by del x plus del v by del y plus del w by del z is equal to 0. So del u by del x, u by x is equal to 4x plus del v by del y and del w by del z is equal to 0 is equal to 0. So del v by del y is equal to minus 4x and del v is equal to minus 4x del y, integrating both sides, v is equal to minus 4x y plus function of this is y, so the function will be remaining except y, so this is equal to function of x and z. So match the answer. So this is equal to minus 4xy plus function of x and z, this constant will be, so option B is the correct answer. This is the velocity field v of an incompressible flow. Next, for ideal gas, the value of Joule-Thomson coefficient. So for ideal gas, the Joule-Thomson coefficient equal to mu is equal to del T by del P. First constant enthalpy is equal to 0 for ideal gas. Option C is the correct answer. Next question. A flywheel is attached to an engine to keep its rotational speed between, just a minute. Uh, and a flywheel is attached to an engine to keep its rotational speed between 100 radian per second to 110 radian per second. If the energy fluctuation in the flywheel between 1.05 kilojoules, then the moment of inertia of the flywheel time to be. So the maximum change in energy, we know the formula, half I omega max square minus omega mean square. So and I have to found omega max given the 1110 square minus 100 square, and change in energy is 1.05 into 10 to the power joule. So in that case we can find I is equal to 1 kg meter square. So option A is the correct answer. Next question. A balanced rigid disc mounted on a rigid rotor has 4 identical point masses, each 10 gram each, attached to a 4 point on the 100 mm radius circle in shown in the figure. And the rotor is driven by the motor at a uniform angular speed given omega is 10 radian per second. If one mass of the get discharged, then the magnitude of resultant unbalanced force on the rotor. So if unbalance is equal to mr omega square, mass given 100 gram, that means 0.01 kg, and radius given 100 mm, that means 0.1 meter, and omega is 10 radian square. For calculating, we get 1 by 1 into 1 by 10 into 100. So that's 100 1/10, which is equal to 0.1 Newton. Answer option A is the correct answer. Next question. The compressor of a gas turbine plant operating on ideal intercooled Brayton cycle accomplished by overall compression ratio. Compression ratio given 6 in a two-stage compression process. Two-stage, and the intercooling is used to cool the air coming out from the first stage to the inlet temperature of the first stage before its entry to the second stage. So air enters the compressor at 300 Kelvin, pressure given 100 kilopascal. If the property of gas are constant and intercooling pressure for minimum compressor work, we have to find the intercooler pressure. That means the intercooler we have to find for minimum compressor work. So we know for intercooler second stage, we know for minimum work it will be P1 into P3. So the compression ratio is 6, which is equal to overall compressor ratio given 6. That means P3 divided by P1, and P1 given 100 kilopascal. That means P3 is equal to 600 kilopascal. So intercooler pressure for minimum compressor work input root over 100 into 600, which is equal to 244.94 kilopascal. So option D is the correct answer. Next question. In a concentric tube counterflow heat exchanger, hot oil enter at 102 degrees centigrade and leaves at 65 degrees centigrade. Cold water enter into 25 degrees centigrade and leaves at 42 degrees centigrade. And we have to find the LMTD. So it is at 102 degrees centigrade and leaves at 65 degrees centigrade, and this is enter at 25 degrees centigrade and leaves at 42 degrees centigrade. So difference is 102 minus 42 degrees centigrade, which is equal to 220 60 degrees centigrade. This is delta T1 equal to 60 degrees centigrade, and this difference is 65 minus 25 is equal to 40 degrees centigrade, which is equal to delta T2 temperature. So logarithm temperature LMTD, we know the formula del T1 minus del T2 divided by ln first del T1 will come del T1 divided by del T2. So it's equal to 60 minus 40 divided by ln 60 divided by 40. So which is equal to 20 divided by ln 3 by 2 is equal to 59.3 degrees centigrade. So answer will be option D. Next question. A strip of thickness 40 mm is to be rolled to a thickness 20 mm is used using a too high mill having roll diameter to 100 mm, and we have to find the coefficient of friction and arc length. So given thickness h1 is equal to initially 40 mm and final thickness h2 be 20. So del h is equal to 50 minus 20 equal to 20 mm, and the roll diameter given 200 mm implies that radius will be 100 mm. So we know the arc length, that means projected length, will the formula root over r del h. So root over r given 100 into del h is, and the difference in height means thickness is equal to 20 root over 2000 is equal to 54.721 mm. Next, you know also one formula, del h is equal to mu square r, and del h value is 20, and mu square we have to found, and r is equal to 100. So mu is equal to 20 by 100 root over of 0.2, which is equal to 0.44, implies that mu is equal to 0.447, which is also equivalent to 0.45. So answer will be 0.45, and projected length given 44.72, and is the correct answer. Next question, the magnitude of reaction force at point C we have to found. This point RC to found in the hinge in kilonewton. So this is the internal hinge. We know for internal hinge the moment is equal to 0. So from the right side we have to take the moment. So RC into 4 is equal to anti-clockwise, and the clockwise moment is, this is the uniform distributed load which act on the middle of the bar, and the value of this value is 10 into, in the length is 4, and it is acted at the distance 2 meter from the internal hinge. So the answer, the right clockwise moment is 10 into 4 into 2. So RC will be 20. So option D is the correct answer. Next question, in the following data applies to basic shaft system. The tolerance of hole is 0.02 mm, and tolerance of shaft is 0.001, and allowance is 0.03 mm. Basic size is 50 mm. Then we have to ask the maximum hole size. For hole size, we have to take basic hole size plus given allowance, plus, and shaft we don't have to take, and because this is asking for hole, so tolerance for holes. So basic size is 50 plus allowance given 0.003, and tolerance of hole is given 0.002. So adding this, it will be 15.005. Option A is the correct answer. Next, in a turning process, Using orthogonal tool geometry with chip length of 100 mm is obtained from uncut chip length. Uncut chip length given is and chip length given 100 mm and uncut chip length given 250 mm. So chip thickness ratio we know. Okay. So the chip thickness ratio, which is equal to LC divided by L, which is no less than must be equal less than equal to, less than 1. So it is equal to 100 divided by 250, which is equal to 0.4, is less than 1. Next, given the cutting condition are speed 30 meter per minute and rake angle alpha given 20 degree, and we have to shear angle found. So phi we have to found. We know the condition tan phi is equal to r cos alpha divided by 1 minus r sin alpha. So putting the value all r given 0.4 cos alpha value 20, 1 minus r 0.4 sin alpha value 20 degree, and tan phi have to calculate it. So phi is equal to tan inverse 0.4 cos 20 degree minus 1 minus 0.4 sin 20 degree. So the answer will be 23.5 degree. So answer option B is the correct answer. So thank you. This completed all the 1 mark question from set 1 2020 mechanical gate. Thank you.